Here comes the tutorial for testing an accelerometer. This is sample code for testing an accelerometer. First, we declare 6 variables: I, X, I, Y, I, Z, X, Y, and Z. The variables I, X, I, Y, and I, Z are for containing the previous values of the 3 axes. X, Y, and Z are for the current values. Then we come to the setup mode, that is the setup function. Then in that we have 3 pin mode functions which are used for setting the mode of a pin to pin of the microcontroller to either input or output mode. In Arduino, or what we say, the chip name is Atmega. In Arduino, it is Atmega 328. Just a second. Okay, sorry, it's not auto focusing. So the microcontroller chip in Arduino is called Atmega 328 from the company called Atmel. Okay, coming to the code, we basically have set 3 pins A0, A1, and A2 to input mode. In the microcontroller, we can't use a single pin for both input and output at the same time. So next we come to serial.begin. We give this serial.begin of 9600 baud rate. This baud rate is nothing but the communication speed between the microcontroller and the computer. This enables serial communication between the microcontroller and computer. I, X, I, Y, and I, Z are initialized using the analog read function. And we come into the loop function. This loop function keeps on executing consecutively every time. In this, first we have first we accept the values of X, Y, and Z using analog read. Then we print the values of X, Y, and Z. Not only X, Y, and Z, but also we print dx, dy, dx, dy, and dz, which are nothing but the difference between the previous value and the current value of the 3 axes. Then we have then we set Ix to X and Iy to Y and Iz to Z. Since it's practically not possible to read the input for every microsecond which the Arduino can generate, we give a delay of 1000 milliseconds so that we will be actually able to read the output. The output we get in the serial monitor can be viewed using this magnifier kind of icon, which opens the serial manager. That's all about the programming part. Now we will go to the electronics. Okay, these are the required electronic parts. This, as you can see, is the accelerometer. This is the Arduino. This is the wire that, or better to say cable, that connects Arduino with the computer. And we have a few connectors here which connect the accelerometer with the Arduino. These have one male pin and one female pin. This accelerometer, in the back side, they have given okay, as it is, it has been given. This is the X motion, which is also called the pitch motion, and okay, this is the Y motion, which is also called roll, and this is the Z motion, which is called yaw. Now we will see about connecting the Arduino to the computer. So it's as easy as connecting your phone to the computer. Just connect this USB to the computer, and this USB type B to the computer, USB type A to the microcontroller. Now let's connect the accelerometer, but I would have to pause the video to connect, as I wouldn't be able to film in one hand and connect. Okay, I've just disconnected the Arduino from the computer, so that there won't be any red LED of the microcontroller or accelerometer glowing, which creates a vision bleach. As you can see over here, the black wire is connected to ground, white to 5 volt, blue to X, green to Y, and yellow to Z. Similarly, in the microcontroller, black is connected to ground, white is connected to VCC, which is another name for 5 volt, and the blue is connected to A0 as per our code, green to A1 and yellow to A2. Now we'll be uploading the code. Okay, I reconnected the Arduino to the computer, and so this we'll be uploading this code. We can either click this upload button, or the shortcut key is Ctrl U. Okay, it's being uploaded. At the same time, I'll open the serial monitor. Okay, sorry, there is a small COM port error. No, sorry, there's no error. I just first let me hold the accelerometer. Okay, just a second, I'll just transfer the filming to someone else. Okay, I won't be able to parallelly do both, show both the serial monitor as well as the accelerometer. So here it goes. When I say I am doing an rotation in positive X, I mean that I am rotating it in this direction. Negative X means this direction. Positive Y means this direction. Negative Y in this direction. Positive Z is in this direction. This direction. Negative Z is in this direction. Okay, now moving on to the serial monitor. Okay, it has started sending me values. First, I am having something like this, and then I am changing the Z to positive Z, then negative Z, then I am giving positive X, positive Y, positive negative Y, positive X, negative X, so that's all about the accelerometer. We can use these values to stabilize quadcopters and whatnot. We can use it to find the angle of tilt of the robot, and so on. There are so many applications, and yeah, that's it about the accelerometer. Now coming to the compactness, we can use this PCB designer, which is very simple to use. We just okay, we have these 5 pins on the accelerometer. We can just fix the pins like this into the board. It will pierce through and come through the other side. Then we can make the connections by soldering the various pins over here. And that's all about the electronics part, and as well as the programming part. So farewell and goodbye.